Hello everyone, let's find out the equivalent capacitance of capacitors in parallel combination. To understand this, let's recall as to what is a parallel combination. So let us take example of three capacitors. Here capacitor like this, capacitor here, so let's take three capacitors which are connected to a battery which can provide a voltage drop of V. Let's call the capacitors as C1, this is C2, this is C3. Suppose if charge Q flows through the circuit, let the voltage drop be V by this. If charge Q flows, this Q finds three possible paths. If the charge comes to the point A, it finds three possible paths. So out of this capital Q, some part goes here. So the charge going would be Q1. The charge going here is say Q2, and charge flowing here is Q3. So charge from here would be, it will be minus Q1, minus Q2, and then minus Q3 here. So this will be positive and negative, positive and negative is what we get. So we saw that earlier, in case of parallel combination, the charge divides, but the voltage drop across each capacitor remains same, which means the drop across this capacitor would be V only. If this is like say 10 volt, the drop across these 2 points will be 10 volt, drop across these 2 points will be 10 volt only. That is, if you take a voltmeter and connect between these 2 points, this will read 10 volts. Similarly, if you take a voltmeter and connect between these 2 points, even that, take a voltmeter here and connect them, even this would read 10 volt only. So the voltage drop across each capacitor is same, which is 10 volt. Now we need to find its equivalent capacitance, which means we need to replace this combination by single capacitor. It's the same battery only. It's again a battery which offers a voltage drop of 10 volt, and then we connect to a capacitor which you call as say C suffix P, which means it is the equivalent capacitance for parallel combination. So what I find here is, we find that in this case, if the voltage drop which this provides say V, if charge Q flows across this, it means that even this capacitor will draw same charge. So the battery will not know whether it is two capacitors or three in parallel, or in this case, the battery will not know whether it is these many capacitors or single capacitor. The effect is same, and that capacitor is called as equivalent capacitor or equivalent capacitance in terms of properties. Now let's try to find out what is the Cp in terms of C1, C2 and C3. Now from here we can say the charge divides. So capital Q, that is charge, is equal to Q1 plus Q2 plus Q3. Let's write Q in terms of C and V. Recall that Q is equal to C into V, which means this Q is equal to, capital Q is equal to, it is Q1. So it will be C1 into V. Because Q is of the form C into V, the voltage drop is same. So there's no need to put suffix V1 here, because the drop across three capacitors is same, plus C2 into V plus C3 into V. From here V is common, so this becomes Q is equal to C1 plus C2 plus C3 into V. Let's call it as 1. Now in this case, if you write for for equivalent, that is for equivalent capacitance. In this case, the form is same. So what you get in this case would be Q, the charge Q is equal to the Cp into V, the same voltage drop called as 2. Comparing 1 and 2, we can say that Cp into V, that is this term, is equal to C1 plus C2 plus C3 the whole into V. So from here V gets cancelled. Therefore what we get is a simple expression which says Cp is equal to C1 plus C2 plus C3. So this is C parallel. We can say that equivalent capacitance in parallel combination is equal to sum of individual capacitances. It's a very simple relationship. If we have n capacitors, that is for n capacitors of values C1, C2, etc., then C suffix p is equal to C1 plus C2, etc. plus Cn. Suppose in this case, if C1 is equal to C2 is equal to C3, all of this is of same value C, then Cp is equal to, it will be C plus C, etc. plus C. So C parallel is equal to n times C. This is the equivalent for n capacitors when all are same value. So as seen here, we found out that the capacitance, that is equivalent capacitance, would be greater than each capacitance value. So the Cp would be more than all the values. Combining them, it will be greater. Now let us look at a diagram or a practical observation of parallel combination. So as seen here, there is a combination like this. So we find this and this are in parallel combination. If you have, for example, all this to a single source of battery, this will be in parallel combination. So this is what is the effective capacitance and parallel combination.